Okay, so for this one, how many kilograms of water does it hold?
Not enough.
Well, first thing we need to find is the volume. So, volume of this will be 0.8 meters times 2 meters times 1.2 meters, which is what, 1.92 meters cubed is our volume. Now we do have a relationship between mass and milliliters. We know that 1 milliliter of water has a mass of 1 gram. But we're not in milliliters. We're not in milliliters is unit of capacity. We're in units of volume. So we've got to somehow change our volume to capacity. But we do have the relationship that 1 cubic centimeter equals 1 milliliter. So I need to change this from cubic meters into cubic centimeters. On my chart, to get from meters to centimeters is 2 spots to the right, correct? So do I move my decimal point 2 spots to the right? Say no. Why not? But it's cubed. So that means each spot on the chart is 3 places. So 2 spots on the chart is 6 decimal places. So 1, 2, and I got to add zeros. 3, 4, 5, 6. So that's 1,920,000 cubic centimeters.
I don't have the right answer.
Does that make sense so far? Looks familiar? How many milliliters is that going to be? Yeah, they're the same. A milliliter and a cubic centimeter are the same. So it's 1,920,000 milliliters. How many grams of water would be in that? 1 gram is 1 milliliter. 1,920,000. Of course, I didn't ask for it in grams. I asked for it in kilograms. Going from grams to kilograms. Is 3 spots to the left. So I have to move my decimal point. Do I have to double it or triple it? Say no. No. I just got to go 3 spots to the left. So that's 1,920 kilograms of water. Or just like 4,200 pounds of water. It's over 2 tons of water. Had the numbers right? Just the units wrong? Similar to that, let's say I give you a tank like this and say that this is 4 feet, 3 feet, and 2 feet. And I ask you how many gallons are in there? This one's a little simpler. My volume is going to be found by doing what? Yeah, 4 feet by 3 feet. 12 square feet times my height of 2 feet, which is going to give me 24 cubic feet. What do I do with that to get gallons? Put cubic feet on bottom. 1 cubic feet is how many gallons? 7.5? Close enough, yeah. Depends on where you look. Some books say 7.48, some say 7.5. We're going to use 7.5 here. Make it simple. So 24 times 7.5. 180 gallons. What you think? Good stuff? Okay. So today we're going to take a look at what happens if I have 2 units. And we've looked at this before. Remember we did the example of me throwing a baseball at 90 feet per second? Do you remember that example? Let's just review that. How did we turn that into miles per hour? We did 90 feet over 1 second. This step right here is the key. You take this 90 feet per second, and you have to be able to put it into a ratio. 90 feet goes on top, and the bottom unit here is just has a value of just 1, a number of just 1. So it's 1 second. And from there we can convert feet on bottom to cross cancel those, going into miles. 1 mile is the 5,280 feet. And then we got to get rid of seconds. Now, since seconds were on bottom, we had to put them on top to cancel them out. 1 hour is 3,600 seconds. So the feet cancel, the seconds cancel. We now have the correct units. On top, we need miles. That's all we have on top. Bottom, we need hours. That's our only unit on bottom. So we can multiply out and divide, or we can do this. This is 90. The 520 or 5280 is on bottom, so we're going to divide by 5280. The 3600 is on top, so I'm going to multiply by 3600. That gives me 61.4 or 61.36. That is miles per hour now. Wow. Let me try that again. Miles per hour. There we go. So what if I have something listed as 500 pounds per square foot? Is that high pressure? Let's say I tell you that a tire has to be inflated to 500 pounds per square foot. They're going to blow the tire to shreds? Is it going to be running flat? What's it going to be? What are we using? What's that? It's going to be running flat? All depends on the tire. What are we used to? What units are we used to tire inflation being listed as? Pounds per square inch. So I'm going to take this 500 pounds over 1 square foot. Remember, the bottom unit goes on the bottom, and it's 1 is the number with it. Do I have to change the pounds? No. I only have to change the square feet. Where am I going to put square feet here in the conversion factor? Has to go on top. It's on bottom here, so it has to go on top so it'll cancel. And I'm changing it to square inches. So that's 1 square foot is how many square inches? 144. If it's square feet and square inches, it's 12 times 12. So that cancels out. So now I do have pounds per square inch. This will be 500 divided by 144. So 3.47. If it's on your larger tractor tires, some of those only have like 5 to 10 pounds of pressure in them. But that's still probably underinflated no matter what that's in. What's that? That's got to be sitting pretty low. Low speeds, but if you're underinflated like that, when you hit high speeds, it starts to sway just a touch on you. You don't have that much to live for, is what you're saying?
No.
Okay.
Hey, Kenny rides my bike too, and he thinks it's more fun with the little guy with that much pressure.
I'm going to say I'm going to hit the freeway and I'm going to get up to 1.3 miles per minute. Am I in danger of getting a ticket? No, you don't think? Well, again, we're used to these speeds being in miles per hour.
1.3 miles a minute.
Yep. Well, we're going to take it 1.3 miles over 1 minute. And again, we don't have to change the miles, we're just changing the minutes. So we're going to put it on top so they cancel. Make this hours. 1 hour is 60 minutes. So the minutes are gone. This is now miles on top and hours on bottom. The 1.3 is going to be multiplied or divided by the 60. Multiplied. The 78 miles per hour. I might be on the edge of getting pulled over there. On the 70 or the 65? In the 70 or the 65? 70?
No, they told me that it's, how did they put it? If you go over 70, you're getting pulled over, because it used to be 65.
Yeah, it used to be when it was 65, they'd usually allow you up to like 72 or 73. And that's why I kind of said, what I read was they didn't expect, when they raised the speed limit to 70, they didn't expect the average speed of the cars to increase by more than 1 or 2 miles per hour, because of the way they're going to enforce it. Yeah. But let's say that we have a pump that says it is capable of pumping 8,000 cubic inches per minute. Is that an effective pump? Well, we're used to pump speed listed in what's called CFM. What's CFM stand for? Cubic feet per minute. So we're going to change this to cubic feet per minute. So again, we're keeping the minutes here. We're getting rid of the cubic inches. So cubic inches go on bottom, cubic feet on top. 1 cubic foot is how many cubic inches? 1,000. 728, or 12 by 12 by 12 is cubed. So the cubic inches are gone. We have cubic feet on top and minutes on bottom. This is going to be multiplied or divided? Divided, because it's on bottom. So it's 8,000 divided by 1728. 4.63. That's not terrible, but usually looking at like 9 to 12 cubic feet per minute.
Well, that'd be a really
4.6 is a small pump. Yeah. Yeah, air compressor is about right. Personal air compressor, not a shop one. You want little portables. I believe I've got one for my finishing nailer that's about 5 or 6 cubic feet per minute. My large one for my framing nailer, I believe, is 9. Otherwise, it won't keep up with it. Oh, let's see. Let's say that you have something rated. The weight on a floor is given as, how do I do this? Let's do it this way. It is given as 4 ounces per cubic inch. Not cubic, ounces per square inch, I should say. We want it listed as pounds per square foot. So it's 4 ounces over 1 square inch.
What are you measuring again?
A weight loading on a floor or a beam. You could also think of it as stress on a post. So I've got to change both, so it doesn't matter which one I do first. I'll do the ounces first. Go into pounds. 1 pound is 16 ounces. So I've got rid of the ounces. For square inches, I'm going to have to put square inches on top to cancel out, going to square feet. The relationship there is 1 square foot is 12 by 12, or 144. So now what we have, pounds on top, square feet is all that's left on bottom. This is 4 divided by 16 times 144. Gives us 36 pounds per square foot. That's actually not far off from your loading for a floor joist, what's allowable. Okay, well, let's do another one. Let's say we've got something listed as one gallon per second. I want you in your notes to try to change that to cubic feet per minute. CFM, basically. See what you come up with. So we start out as listing this as 1 gallon over 1 second. Let's change the gallons first. We're changing gallons into cubic feet. 1 gallon is, we're going to go, or 1 cubic foot is, we're going to go 7.5 gallons, make it easy. So it's either 7.48 or 7.5. We'll stick with 7.5. So that gets rid of the gallons. Now what do we have to do? Seconds to minutes. The seconds were on bottom, so I had to put them on top to cancel. 1 minute is 60 seconds. So now all we have left is cubic feet over minutes. So it's cubic feet per minute. And so we've got 1 divided by 7.5 and times 60. Does give us 8 cubic feet per minute. Any questions?
How do you know when the times are divided?
Okay, so we're starting out here, right? This one, the number's on bottom, so we divide by it.
Oh,
This one, the number's on top, so we multiply by that.
oh, okay.
The other one thing you can do is you can just multiply straight across and get 60. Straight across here and get 7.5, and then just divide it out at the end.
Oh,
Either way works. I'm just kind of doing a little bit of a shortcut.
Do you really have to times it by 1 then?
Not really. You notice how I punched it in the calculator?
I didn't even see that.
Yeah, I just did 60 divided by 7.5.
so in any conversion you're doing, you can just go straight across. on
Yep.
both and
Multiply the whole
and bottom.
top, multiply the whole bottom, then divide it out. And that's technically what you should do, the long way of doing it. I'm just shortening it up a little bit here. So what if I tell you something has a density of 0.2 ounces per cubic inch? What's that going to be in pounds per cubic foot? Give that one a shot for me quick. 0.2 ounces over 1 cubic inch. Let's do the cubic inches first with that. 1 cubic inch, or cubic inches on top, cubic feet on bottom. 1 cubic foot is 1728 cubic inches. That'll cancel out the cubic inches.
Does it really matter what order we do it?
Nope. I could have done the pounds and ounces first. Really makes no difference. Yeah, these two conversion factors, I could put this one first if I wanted to. It really don't matter. So now the ounces are gone. I am left with pounds on top, cubic feet on bottom. So we've got the right units. So 0.2 times 1728 and then divided by 16. $21.6 pounds per cubic foot. What do you think? Still better than a sharp stick in the eye?
Sometimes.
Let's talk metric for a while. Metric, well, depends on what we're converting. If we have both units as metric units, it's actually really simple. But if we're just converting one unit, then we've got to be a little bit careful. You know, for example, let's say we are converting is 30 meters per second. Is that pretty fast? Well, let's convert that into kilometers per hour. So make this 30 meters over 1 second. Pretty quick? Put seconds on top, hours on bottom. 1 hour is 3,600 seconds. That makes the seconds go away. I'm going to actually multiply this out now and get meters per hour. 30 times 3,600 is 108,000 meters. 1 times 1 hour is 1 hour. Now, to change the metric part of it, I'm just moving the decimal point. I'm in per hour right now. 1 hour's on bottom. I got to change my meters to kilometers, which is just moving my decimal point 3 spots to the left. So that's 108 kilometers per hour. Now, I could leave it as kilometers per hour, but we don't have much of a clue what kilometers per hour means. So let's take that 108 kilometers per hour and change it to miles. But kilometers here, miles there. 1 kilometer is about 0.6. It's actually like 0.624. But 0.6 is what your book seems to be using. Miles. So the kilometers cancel out. We're left with miles per hour. 108 times 0.6 is 64.8 miles an hour. What if we have 2.8 kilograms per centimeter squared as a pressure? And we want to figure out what is that in grams per millimeter squared. Now here, both of the units are metric units. This is 2.8 kilograms over 1 centimeter squared. We're changing kilograms to grams and centimeters squared to millimeters squared. I'm not going to use any conversion factors here. I'm just going to move decimal points. 2.8 kilograms is how many grams? If I move my decimal point, kilograms to grams is 3 spots to the right. So move my decimal point 3 spots to the right, we'll make that 2,800 grams. 1 centimeter squared is how many millimeters squared? Well, centimeters to meters on the chart is 1 spot to the right. But it's squared, so we have to go 2 spots. So going 2 spots, that's 100 millimeters squared. Now we do still have to divide this out. 2,800 divided by 100 is 28 grams per millimeter squared. Notice the number itself shouldn't change as the decimal point moves. So it's a matter of changing the decimal place. Or you might have something stated as a concentration, a medical concentration, or you guys were asking about antifreeze concentrations. You might have a mixture that is 3.4 grams per milliliter. You might want to know what is that in kilograms per liter.
I don't know what that is for like gallons and
Yeah,
not.
we'll look at that too.
You make things so difficult.
So we have 3.4 grams over 1 milliliter. We're changing grams to kilograms and milliliters to liters. Grams to kilograms is 3 spots to the left, right? So I move my decimal 3 spots to the left. Add my zeros, that is 0.0034 kilograms. Milliliters to liters is also 3 spots to the left. So I move my decimal 1, 2, 3. That is 0.001 liters. Divide that out, that's 3.4 kilograms per liter. End up with the same number.
You wanna know what makes more sense? Write down.
Now you'd ask, what if it was like ounces per gallon or something like that? Let's say you've got something listed, like mixing like 2-cycle oil or something like that, and they tell you that you need to mix 4 ounces per quart. You want to know, okay, what is that in pounds per gallon? A lot of times they do ounces per gallon.
Makes more sense.
So 4 ounces per 1 quart. We're going to, now since these are standard units, we're going to have to go ahead and do these conversions. 1 pound to 16 ounces, that gets rid of the ounces. And we have quarts, we're going to have quarts and gallons. 1 gallon is 4 quarts. So what we have here, the quarts are gone. We have pounds per gallon. 4 divided by 16 times 4 gives me 1. So that's 1 pound per gallon, or 16 ounces per gallon. That's a little rich. Usually they go like 8 ounces per gallon. Is I think the highest I've seen them mixed. Usually it's like 5 to 7 or something, isn't it? But you guys get the picture. Fuel stabilizer is a lot of times listed as 1 pound per gallon, depending on what you get, either 8 ounces or 16 ounces per gallon. Okay. What's that?
I don't know.
Yeah. A lot of times you just dump one can into a tank, but if you look at it really closely, it does have broken down. I always just try to take my snow blower and my lawnmower and stuff and run them dry at the end of every year, or close to dry at the end of every year. In your packet I gave you, page 238, problems 57 through 64, deal with the dual units and standard units. And page 266, problems 55 through 62, deal with dual units and metric units.